Let's take a look at this example. Again, before we are going to start our analysis, we're supposed to redraw the circuit. So one more time. Anytime we have 0 next to the input, right? This is the input terminal. It means that this input terminal is connected to the ground. Okay, I'm going to draw dashed line just to make sure that you are going to understand that you have to have this connection in your mind. You can always draw it, but if you don't want to draw it, you're supposed to just keep in mind that anytime you have 0, it means automatically that this terminal is connected to the ground. Anytime you are going to see negative 10 volts, it means that you are going to have connection from this terminal, this input terminal, right, to the negative terminal of my power supply, which has also voltage across itself 10 volts, okay? So that's why I have negative 10 volts over here. Next, I'm supposed to check which diode is conducting, which diode is working. I just look at the polarity of my power supply, and I'm saying that this power supply has connected the positive terminal to the ground. So it means that the current is going to be pushed to the ground. If it's going to push to the ground, it means that the current in the loop, I can call this in the loop with the diode D2, is going to flow theoretically clockwise. Okay, so if it's going to current, if it's going to go this way clockwise, it's going to go in exactly the same direction which is showed by the symbol of the diode. Okay, so this diode is going to be in the on state. Okay, why? Because voltage source is much greater than 0.3 volts because it's a germanium diode, right? And the direction of my current matching the direction showed by the diode symbol. So this diode is working, and then we are going to stay with it at this moment. So anytime current is entering the diode, I'm supposed to write positive sign. Anytime is leaving the diode, I'm supposed to write negative sign. Next, I'm supposed to find output voltage, because on my way to ground, going by the diode, I do not have any resistors. I can find output voltage right away, and you can simply write that Vout is equal negative voltage across the germanium diode. Okay, because after that we have just connection to the ground. So Vout is equal negative VD2, which is equal negative 0.3 volts. Okay, so this is my output voltage. Next, we're supposed to find the current which goes through the resistor. In order to find the current, we're supposed to find the voltage first. Voltage across this resistor is the difference of the voltages, Vout minus the voltage at this point. I'm going to call this VA. Okay, let's call this point A, and I'm going to call this VA. So VA, right, is the voltage simply across what? Voltage source. But because I have negative terminal first, so I'm going to measure VA equals negative voltage source. So VA is equal negative 10 volts. So VR is equal Vout minus VA. So Vout is equal negative 0.3 volts minus VA, and VA we said is equal negative 10 volts. So I have negative 10 volts. So I have VR equals negative 0.3 volts plus 10 volts is equal 9 9.7 volts. Okay, so this is voltage across this resistor. Next, we're supposed to find the current which goes through the resistor. So IR is equal VR over resistance, where VR is equal 9.7 volts over 1 kilo. This is equal 9.7 milliamps. Okay, so this is the current which goes through the resistor, right? And this is also the current which will go through the diode D2. Okay, so I can write that ID2 is equal to IR, and this is equal 9.7 milliamps. Next, I'm supposed to find ID1. Now let's take a look at ID1. Now we can talk about it because we found the output voltage and we also know the potential at point VA. So Vout we said is equal negative 0.3 volts, right? And voltage at point A, I suppose to say VA, is equal negative 10 volts. So please notice that I have higher potential because negative 0.3 volts is the higher potential than the negative 10 volts. So if you apply, right, higher potential to the cathode of the diode, right, and lower potential to the anode, right, positive terminal of the diode, so the diode is in the off state. The diode is not conducting, the diode is not working. Okay, in order to make the diode working, you're supposed to have always voltage at the anode higher, right, than voltage at the cathode, right? Of course, if we talk about the germanium diode, the voltage at the anode supposed to be higher than 0.3 volts than the voltage at the cathode. Okay, so because at this moment we have higher potential at the cathode than anode, the diode is in the off state. So we can say that the diode is not conducting, and I can write that ID1 is equal 0 amps. Next, we're supposed to find PR. PR is equal the current, right, which goes through the resistor raised to the second power times the resistance. So I have 9.7 milliamps raised to the second power times the resistance 1 kilo ohm. This is equal 94.09 milliwatts. Okay, so this is the power at my resistor, and we can say that the problem is solved.